All right, chapter 7.4. The work for this week is focused on a few topics. Again, if you can take good notes, practice efficiently, and make sure you ask for assistance when needed. It should be a fairly simple week, even though we do have 3 sections to go through. Today we solve logarithmic equations. This section will require just mainly common sense and experience with evaluating logarithms. Hopefully you used last week to do that. Pay attention to the explanations, and again, be sure to write down your own translations to assist you for understanding later. For example, if I say something during the explanation that helps you remember it that I did not write down, then you should write down whatever it is that I said so you have a little note whenever you're studying your notes later on to understand why I did what I did. In the first one, this one here is an introduction to what we call a common logarithm. And a common logarithm is just log, kind of like square root, as we've learned, has an invisible 2, how everything is going to the power of 1. Your invisible number here is log base 10. So whenever you just see a regular log, that is a base of 10. And so whenever you see this and you can't separate the log from the x, again, in my opinion, I would just rewrite it. So you'd have a 10 to the 2.67 power equals x. Remember that from last week, where again, you take the base to the power equals the exponent, or base to the exponent equals the power whenever you rewrite it, which means from there all you have to do, because we do have a calculator for that, is 10 caret 2.67. And again, whatever answer they say rounds to the nearest hundredth, which means 2 zeros because 100 has 2 zeros in it. So it'll be 467.74 as your value of x. So again, just kind of focusing on the skill sets, focusing on making sure you at least know what to do whenever you see certain things going on. Same thing here. You have solve log base 81 of x equals 5/4. Again, I don't know how to get the log of 81 off of x, but I do know that I can at least consider writing this as 81 to a power equals x, because remember, those two will switch spaces. So if I rewrite this in exponential form, then all I have to do is take my calculator and do 81 to the 5/4 power, which gives me 243. So again, skill sets basically is what we're working on, making sure you're used to at least doing the two things, especially if you don't know how to translate. That's going to hurt you later on. This is where the common sense comes in. Says log base 5 of 10x plus 44 equals log base 5 of 2x plus 20. And the key thing to think about is the problem where we had 2 to the x plus 5 equals 2 to the 2x plus 7. And what we said was, because both of these bases were the same, that they could actually be ignored, and we just focused on these. Same thing here. You have the log base 5 of something equals the log base 5 of something else. In all honesty, all that should happen is that this should equal that. Alright, so in general, that's pretty much what's going on there. Alright, so with that said, move your 2x over, which makes 8x plus 44. Subtract your 44 over here, which means that you end up with 8x equals, I believe, negative 24. And then divide by 8, giving us x equals negative 3. Checking that out, negative 3 makes negative 30. Negative 30 plus 44 is 14. Negative 3 here makes negative 6. Negative 6 plus 20 is also 14. So again, we know that that does work. And as you can see, it's even quick video today. I think a lot of your videos this week are going to be quick, actually, for the next 2 weeks. Just, again, instead of having to worry about all other stuff, because it is based on skills. So here we have the same situation. Log base 6 of something equals log base 6 of something else. So therefore, to me, I'll just put z to the 4th plus 36 must equal 13z squared. And again, what I learned before is that whenever I have a variable to a power higher than 1, that it's an elephant on the boat. Of course, it's going to fall to the biggest variable, so 13 squared, 13z squared is going to come over here. When it moves, it should become negative because it's positive over here and it switches places. So z to the 4th minus 13z squared plus 36 equals 0. Now, the other thing that we learned in a couple chapter ago or so is that whenever this power is half of that power, and it goes that way down to 0, that we can still factor it. We would just use z squared in our numbers. So we're looking for numbers that multiply to be 36 and add to equal negative 13. To me, those numbers are negative 4 and negative 9. So I end up with z squared, because that's what our middle term is, minus 4, and z squared minus 9 equals 0. From there, I have two options. I'll show you both of them. Option one is take this thing and set it equal to 0, which means then that z squared is equal to 4, which means when I square root both sides, you cannot forget to put a plus or minus 4. That is one option. The other option, whenever you have this, is to say that could be factored and turn z squared minus 9 into z plus 3 and z minus 3, which means then your answers are -3 and +3. But again, notice this gives me a positive -4 because of the square root. This gives me a positive -3 because of the difference of squares. As long as you understand those are your four answers, 4, -4, 3, -3. However you put those, again, I'm not sure what the computer accepts, but as long as those numbers match, if there's an issue, just email me and I'll check it out and get you the points you need. And then another one here, which is the last one we're going to talk about, which is where we have log base 9 of something equals log base 4 of something. We cannot use our common sense part here because these two are not the same. What we have to do instead is ask ourselves, do we know enough to make this simpler? In other words, remember whenever you had an equation like 2x plus 1 plus 3 equals, let's say, 6, this isn't ready to solve, but we could write it in a better way. And that made it easier, so simplifying was part of it. What about log base 4 of 2? Let's look at that for a second. Again, if you worked on your evaluation, I know I'm supposed to put 4 to the x equals 2. And what I know about that is that if I was to take 4 and turn that into 2 squared to the x, that means that 2 to the 2x equals 2. Again, that's 2 to the first, which means that 2x equals 1, and therefore x equals 1/2, which means this actually is log base 9 of x squared minus 2 equals 1/2. Using that to my advantage, now we're in a spot to where I can't use this equals that, but I do know that I could put 9 to the 1/2 power, because again, that's your converting it into exponential form, equals x squared minus 2. And then going from there, 9 to the 1/2, I believe that's a square root of 9 if I remember our rules right. Because remember, the fractional exponent is the same as a root. So 9 to the 1/2 equals, look at how it ends up nice for us. So 3 equals x squared minus 2. Move your 3 over by subtracting, you end up with 0 equals x squared minus 5. I don't know why I did that. Move your 5 over, I guess. 5 equals x squared. And from there, square root your answer. And the square root of 5 is 4 decimal places. So 2361. Now, it is plus or minus. I don't think that the computer is going to ask for the positive and the negative. I think it's just going to ask for the positive version. But again, just adjust your answer. If you get it right, but you don't think you should have missed it, just email me and let me know. I'll be glad to check that out. But again, I'm pretty sure that even though there are 2 answers to this, make sure you understand that I think the computer only wants the positive version of that answer. So again, write that down and kind of jot that note. But other than that, keep in mind your focus is on learning strategies. As you practice problems, strategies become part of your problem-solving process. My skill in solving problems pretty much in class and on video comes from having a huge collection of strategies that I've learned through experience and practice. So again, a lot of what I know how to do is because I've seen so many problems that I know how to kind of play with ideas that I've used before while solving a problem. For example, whenever you've heard a riddle, a person rides into town on Friday, stays 2 days and leaves on Friday, and you understand the answer to that joke is because he rode in on a horse named Friday, all of a sudden that solution becomes part of every time you hear a riddle that maybe they, that name was, the day was a name or whatever it might be. But anyway, even though you might not be following that, what I'm saying is the process you use to solve one riddle is potentially useful in solving another riddle. And so once you know the answer to that, you use that as a potential option. And so what I'm saying is I've worked so many things that I know how to kind of say, well, maybe it's like that problem, maybe it's like that problem, and eventually figure it out. But make sure you understand to recognize when a portion of the problem is insignificant. For example, when I have log base 3 of x plus 5 equals log base 3 of 7, that I can ignore those log base 3's and just do x plus 5 equals 7. Or whenever it's in your best interest to convert to exponential form. Again, if I have log base 3 of x plus 5 equals 2, I can't use the insignificant part, but I can put 3 squared equals x plus 5. And then again, recognizing when to just simplify a logarithm to make the problem more manageable. That is similar to when we saw log base 4 of 2 on one side, and we couldn't do anything because the other one was not a log 4, but we could convert log 4 base 2 because we do have that experience. So again, just be sure to contact me if you need assistance. Also be sure to show me your work so I can assist your decision-making skill. Outside of that, good luck, and again, easy video today.